Welcome to Topic 3, Unit 1, Verifying Trigonometric Identities. First, we're going to start by looking at a summary of the basic trigonometric identities that we've already learned. We've learned the quotient identities, that tangent is sine over cosine and cotangent is cosine over sine. We have learned the reciprocal identities where cosecant and sine are reciprocals, secant and cosine are reciprocals, and cotangent and tangent are reciprocals. We have learned the cofunction identities, where, for example, sine of theta is equal to the cosine of pi over 2 minus theta, or the cosine of 90 minus theta. We've learned the Pythagorean identities, the basic one, sine squared plus cosine squared equals 1, and the other two, the one that relates tangent squared to secant squared, and cotangent squared can be related to cosecant squared. And finally, the even-odd identities, which are basically going to allow us to do something with a negative theta that's inside the function. If a function is odd, like sine of theta, then sine of negative theta is equal to the negative sine of theta. Tangent, cosecant, and cotangent are all odd functions. Cosine is even, which means the cosine of negative theta is exactly the same as the cosine of theta. Its reciprocal secant theta is also even. If you have not already done so, these identities should be transferred onto your identity sheet that you started at the beginning of this topic. Example 1a, simplify cotangent theta, cosecant theta by rewriting each trig function in terms of sine and cosine functions. Well, I know that cotangent is cosine theta over sine of theta, and cosecant is equal to 1 over sine of theta. Dividing fractions is like multiplying by a reciprocal, so this is equivalent to multiplying by the sine of theta over 1. The signs cancel, and this simplifies to just cosine of theta. B. Show that cosine theta over 1 plus sine of theta equals 1 minus sine theta over cosine theta by multiplying the numerator and the denominator of the left side by 1 minus sine of theta. So 1 minus sine of theta times cosine of theta over 1 minus sine theta times 1 plus sine theta. Notice that the denominator are conjugates, so this is going to distribute into 1 minus sine squared theta, and I'm just going to leave the numerator alone because I want to have 1 minus sine of theta in the numerator, so I don't want to distribute. Now think about your Pythagorean identity. Sine squared theta plus cosine squared theta is equal to 1. Well, if I subtract sine squared theta from both sides, I get that cosine squared theta is equal to 1 minus sine squared theta. So I'm going to replace 1 minus sine squared theta with cosine squared theta, and then I can take 1 cosine theta and cancel it with one of my cosine thetas in the denominator, and I get 1 minus sine of theta over cosine of theta, which is what I was asked to get to. Part C, simplify 1 plus sine u over sine u plus cotangent u minus cosine u over cosine u by rewriting the expression over a common denominator. Well, when we look at the two denominators, they don't share a common factor. So my common denominator is going to be sine u cosine u. So I'm going to multiply the left term by cosine u over cosine u, and I'm going to take the right expression and I'm going to multiply it by sine u over sine u. I'll distribute, and I'm going to get cosine u plus cosine u sine u plus sine of u times, remember cotangent u is cosine u over sine u. I'll plug that in. And then sine u times negative cosine u is negative cosine u sine u. And this is all over my common denominator of cosine u sine u. Now when we look at the numerator, there's some canceling that can happen. Positive cosine u sine u cancels with negative cosine u sine u. The sine u's cancel here, and all I'm left with is a cosine u plus a cosine of u, which is 2 cosine of u over cosine u sine u. My cosine u's cancel, and I've got 2 over sine of u, but 1 over sine of u is equal to cosecant, so finally we get to 2 times cosecant u. D. Simplify sine squared u minus 1 over tan u sine u minus tan u by factoring. So if I factor the numerator, notice that that's the difference of two squares, so that becomes sine u plus 1 times sine u minus 1. And in the denominator, I can factor out a tan u from both terms. So I have tan u times sine u minus 1. My sine u minus 1's cancel, and I get sine u plus 1 over tan u. We practice simplifying trigonometric expressions to get us ready for verifying identities. To verify an identity, you simplify the function on one side to look exactly like the other side. Until the identity is verified, we cannot assume the equal sign is valid. Put a question mark on top of the equal sign and don't use any of the properties of equality to manipulate both sides of the equation. Let's practice. Example 2. Verify cosecant theta tangent theta is equal to secant of theta. So I'm going to put a question mark over the equal sign, and I'm going to work on the more complicated side to make it look like secant of theta. So I'm going to start by replacing everything with sine and cosine. Cosecant theta is equal to 1 over sine theta, and tangent theta is equal to sine of theta over cosine of theta. My sines cancel, and now I have 1 over cosine theta. Does that equal secant of theta? Well, from our reciprocal identities, we know that 1 over cosine is secant theta. So secant theta equals secant theta, and I have verified it. Notice that I didn't skip any steps. I didn't do any steps in my head. I did not multiply both sides of the equation by anything because it wasn't an equation. I am restricted to working on only one side to make it look like the other side. Let's try the next one. Example 3. Verify sine squared negative theta plus cosine squared negative theta is equal to 1. Well, we're going to start by using our even and odd identities. We know that sine is odd, so that means that sine of negative theta is equal to negative sine of theta. And we're still going to square that. And we know that cosine of theta is even, so cosine of negative theta is the same as cosine of theta. So I'll just get rid of the negative, and I'll set that equal to 1. Now when I square negative sine of theta, that becomes positive sine squared theta. And we know from our Pythagorean identity that sine squared plus cosine squared equals 1. Whoops, I forgot my question marks. And 1 equals 1, and I have verified it. Our next example is example 5. We're going to verify 1 plus tangent u over 1 plus cotangent u is equal to tangent u. Again, we usually start with the more complicated side, so I'm going to work on the left side. But keep in mind what the right side is equal to. We want to simplify this whole thing down to tangent of u. So it might be helpful if I make everything on the left side in terms of tangent of u. So I can replace cotangent with 1 over tangent. So I have 1 plus tangent u over 1 plus 1 over tangent u is equal to tangent of u. Now I have a complex fraction. I can fix that by multiplying the numerator and the denominator by tangent of u. I'm tempted to distribute the numerator, but I'm hoping that 1 plus tan u is going to cancel with something, so let me just distribute the denominator. So this is still, the numerator is tan u times 1 plus tan u, and when I distribute the denominator, I'm going to get tan u plus 1. Well, that's the same as 1 plus tan u, and so finally I get tan u equals tan u, and we're verified. Example 6, we're going to verify sine theta over 1 plus cosine theta plus 1 plus cosine theta over sine theta is equal to 2 cosecant theta. Whenever you see two fractions being added or subtracted, you should get a common denominator and do that addition or subtraction. So my common denominator is going to be 1 plus cosine theta times sine theta, which means the expression on the left I'm going to have to multiply by sine of theta over sine theta, and the expression on the right I'm going to have to multiply by 1 plus cosine theta over 1 plus cosine theta. And I'm trying to show that this is going to simplify to 2 cosecant theta. Well, sine times sine is sine squared. It's going to have sine squared theta. Now if I were to distribute this right here, I'm going to get 1 plus 2 cosine theta plus cosine squared theta, and this is all over sine theta times 1 plus cosine theta. And we want to know, is this equal to 2 cosecant of theta? Now if I rearrange the top, I'd like to put sine squared plus cosine squared next to each other. So I can say I have sine squared theta plus cosine squared theta plus 1 plus 2 cosine theta all over sine theta times 1 plus cosine theta. Is that equal to 2 cosecant theta? I know it's tedious copying over the right side each time, but you need to do it. Now we know that sine squared plus cosine squared is equal to 1, and 1 plus 1 is going to be 2 plus 2 cosine theta over sine theta times 1 plus cosine theta. Is that equal to 2 cosecant theta? Well, I'm going to have to continue my work up here. I can factor out a 2, and I'm going to have 2 times 1 plus cosine theta over sine of theta times 1 plus cosine theta. Is that equal to 2 cosecant theta? Well, the 1 plus cosine thetas cancel, and I can rewrite 1 over sine of theta as cosecant theta. So 2 cosecant theta equals 2 cosecant theta, and I'm finished. So let's talk about a few guidelines for verifying identities. 1, it is almost always preferable to start with the side containing the more complicated expression. It's usually easier to simplify than it is to build. 2, rewrite sums or difference of quotients or fractions as a single fraction. Get a common denominator. 3, sometimes rewriting one side in terms of sine and cosine functions only will help. And 4, always keep your goal in mind. As you manipulate one side of the expression, you must keep in mind the form of the expression on the other side. That's all for now. Thanks for watching.